Section 4.3a, excursion polynomial models. Nonlinear regression is sometimes called curvilinear regression. The minimum number of data points required for a polynomial regression depends on the model you're trying to look at. Quadratic, you have to have at least 3, cubic 4, and quartic 5. And of course, if we were really doing some good data, you'd want to have a lot more than that. Example 1. The following data, which is based on stats from the Department of Health and Human Services, gives the cumulative number of reported cases of AIDS in the U.S. from 1982 to 2000. Find a quadratic, cubic, and a quartic regression equation and determine which equation best fits the model. If we look here, I'm going to say let x equal 0 correspond to 1980, so we don't have to plug in all these years. Normally, if it doesn't say that, you would just plug the years in, but just to make it a little bit easier on us. So if 0 corresponds to 1980, then 1982 would be 2, 84 would be 4, 6, 8, 10, 11, and so on. So the years are going to be list 1, and the cases are going to be list 2. So you're going to want to get out your calculator, and so you can do this with me. In your calculator, of course, we're putting stuff in our stat plot, so stat and enter on edit. If you have stuff in your list, remember you can highlight it, hit clear, and then push down. I've already entered into my list, so why don't you pause this video and enter it on your own. Now that you have the list entered in L1 and L2, we're going to go back to our home screen, and we want to calculate some stuff. So let's go ahead, and it didn't ask us to do linear, but I'm going to go ahead and do linear anyway, quadratic, cubic, and quartic. Now, I'm going to make the screen a little bit smaller. Okay, so stat, calculate. Didn't ask me to do linear, but I'm going to do it anyway. So 4, and then I'm going to put this into my y1. And of course, we're going to look at our coefficient of determination, which is your r squared. It tells us how good the line fits the data. So for linear, now I'm going to go ahead and do quadratic. Oops. And I'm going to put this into y2. Then I'm going to do cubic. And I'm going to put this into y3. And the last one is quartic. And I'm going to put this into y4. I'm going to scroll down to look at my r squared. Now before, we just would look at our coefficient of determination, r squared, to see how well our data fits our model. If you look at all of these, notice that the quartic regression has the best coefficient of determination. It's 0.9986. So before, we'd just say, based upon that, we know that the quartic model is going to be the best fit. So let's go ahead and look at this graph. So you need to turn your stat plot on, which mine is, and make sure you're in list 1 and list 2 right here. And then remember, hit zoom. 9 gives us a nice window for our stat plot. So there's the first linear equation. And I'm going to go to my y equals and turn these other ones on so we can look at all of these together. Okay, so now if I hit graph, linear is going to be first. The next one is going to be my quadratic model, then my cubic model, and my quintic model. So they're all pretty close together, so it's kind of hard to tell what's going on. What I want to do is I'm going to change my window a little bit, my x value maximum, and I'm going to change it to, let's do maybe 50, just to show you what's happening in the long run. So I know linear is not going to be the best. There's quadratic. Cubic and quartic. So I need to make that a little bit larger. So I'm going to do 100. All right, so now if we look, I got it to start working. If we look at our graphs in the end, so this would be the cubic, and then this one's going to be the quartic. So notice that in the long run, our cubic and quartic graphs are going down. That would mean that in this case, in the long run, that we would have to find some cure and some people would have to start being cured of AIDS. However, if you think about this equation, if it's the cumulative number of reported cases of AIDS, that means that since we don't have a cure, it's going to keep on going up. So according to our R squared value, so if we go back to here, so the quartic fits, quartic model fits best for the given years. However, in the long run, since there is no cure for AIDS, the quadratic model would be the best fit model. And again, the reason that is because if you think about the context of the problem, it didn't just say for the given years what is going to be the best model. We want to think about what's going to happen in the long run. So if it says, you know, just for the given years, then quartic would be your answer. If it said in the long run, then a quadratic model would be the best fit. So it kind of just depends. So I'm going to go ahead and write down the model for quartic. Y equals negative . So since these get to be quite long, if you want to round to the nearest hundredth, that's okay. So that would be my quartic model for the given years, and then if we wanted to, we could also write down the quadratic model for the long run. I would also write down on your paper as well what our coefficient, our determination was for each of them, so the r squared values you could write over here. So then your homework is going to be to do on the other side, the back side, I want you guys to do question 2 and question 3 and question 4.